Hello friends, today I am here to discuss about the most important or the most difficult subject of engineering mechanics. And I am here to tell something about the mechanics, and those things will help you a lot. So in general, in the student's mind or in the engineering community, so there is always fear about this subject. Engineering mechanics means very difficult subject, horrible subject, or this is the only subject where major students fail. But I feel if we go through this subject neatly, so probably the most interesting subject of engineering. And that is the only reason that from last 25 years I am dealing with this engineering mechanics subject. The requirements of these subjects are what? Actually, we must know the basic things. And if we know the basic things, then we'll enjoy this subject. And without basics, if we are trying to study this subject, then no doubt it is going to be a difficult subject. So first, in very simple words, I'll tell what is engineering mechanics. So engineering mechanics is nothing but it is the study of the application of the forces on a body. So in simple word, study of application of forces on a body is nothing but engineering mechanics. Then basically what we must know that this subject is application of the forces on the body, we must know each and everything about the force, or exactly force means what. And if we know it, then we'll start understanding this subject. Then what is force? Force is, it is a physical quantity which changes or tends to change the physical state of a body. And for the force, what is important? Its magnitude, then its how it is directed. Or force is a vector quantity, means it always needs the magnitude, direction, and at the same time for the force the most important thing is what? Where it is applied. Point of application is equally important in case of the force. So these things you have to keep in your mind. And in general, the unit of the force is Newton. And what about the direction? What about the direction? So mostly we tell in general the direction is upward, downward, towards right, towards left. But when it comes to the mechanics, so directly while solving the problem, we cannot tell that it is towards right, towards left, and we can't make the calculation. So in the mechanics, direction is given by the angle. Means for example, if it is vertical, it is 90 degree. If it is towards right, it's 0 degree. Like that, in the mechanics, direction means angle. Means even though somewhere if the question is there, find the direction, then what you have to do? You have to find out the angle. So these things you have to keep in your mind. Means force neatly we must understand. And for the force, the basic requirement is its magnitude, direction, and point of applications. At the same time, few basic things about the force also we must know. And those basic things generally students learn in 11th, 12th also. But they don't study at that time that we are going to use somewhere in the future in the engineering. Only they prepare those as an exam point of view. So instead of that, at least henceforth, the engineering students must prepare each and everything in by keeping in the mind that in the future we are going to use it. And if that mindset is there, students will start understanding, they will start remembering, and then subject will become very simple. So for the force, not only basic that magnitude, direction, point of applications, along with that line of action also, it is very important how it is acting, and that line of action. So whenever I'll start teaching this subject topic wise, at that time I'll explain in detail, but line of action for the force, it is very, very important. Along with that, in general we must know what do we mean by concurrent forces, coplanar forces, collinear forces, parallel forces. Concurrent means if the lines of actions of all the forces they are meeting at a point, concurrent forces. If not, non-concurrent. If lines of action of all the forces, they are lying in a single plane, then coplanar. If not, non-coplanar or space forces. Then collinear. If all the forces are having a single line of action, or if they are acting in a single line, then those forces are called as collinear forces. And parallel forces. If lines of action are parallel to each other, then those are called as parallel forces. If not, intersecting or non-parallel. So such very basic things already we have studied, just we have to recall. Then after that, so just by telling something about the force, I'll tell, so what basically we have to learn in this subject. So when we are applying the force on the body, and if that body is moving, then it is dynamics. And if body is not moving, then it is statics. Means mechanics is divided into two separate parts. So one portion is statics and other portion is dynamics. So and both are equally important. So as per the static is concerned, after the application of the force, body is not moving. For example, the building in which we are standing. So even though our weight is acting, lot many forces are acting, but it never moves. Means somewhere the requirements are what? Object should not move. So their static is very important. And sometimes motion is needed. So at that time dynamics is very important. So and in general, in the statics, whatever the problems in the statics are there, so generally those are little bit repeated one. Means once we know some fixed procedure, easily we can solve the problems of statics. So in general, students find statics simple. The reason is what? Repeated or similar problems are going to be there. That is the only reason. Then other part is what? Dynamics. So as per the dynamics is concerned, when we apply the force on the body and if that body moves, then that portion of the mechanics is called as dynamics. At the same time, dynamics is divided into two parts. So one is kinematics and other is kinetics. Then in short, I'll tell what is kinematics and what is kinetics. So one thing is definitely must, and that is what? The application of the force for the motion. But in the dynamics, while making the analysis, while solving the problem, if we consider the force, that part is kinetics. And if we do not consider the force in the analysis, then it is kinematics. Again there will be a question, if the force is not considered, then how the motion will be there? Motion is going to be there, we are going to apply the force also, only we are not going to consider. One of the best example I'll tell, if I throw something, I can express it by two ways, that I am throwing the ball with 50 Newton force, then it comes under kinetics where force is considered. Then other way is what? Because of that 50 Newton force, if that object is moving with 20 meter per second velocity, then the same thing I'll tell, I am throwing the ball with 20 meter per second velocity. Here force is not in picture, but its effect in the picture, that is velocity. So like this dynamics is divided into kinematics and kinetics. For all the students, a very simple technique I'll tell. So how to differentiate kinetics and kinematics? When Newton is present, that is kinetics, and when Newton is absent, that is kinematics. What is Newton? Actually here we considered it as a unit of the force. Means somewhere in the problem, if Newton is not there, means those problems are of kinematics, and when Newton is there, it is a kinetics. So again, so as per the kinematics and kinetics, as I told, in terms of force or in terms of Newton, one more way, that generally all the students, they are knowing three equations which are called as actually equations of motion, but in 11th, 12th or earlier you are knowing those are the kinematic equations. And each and every engineering students, when we raise this question, that tell the equations of motion or kinematic equations, 100% they tell in a correct way. V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus twice. But remember that So there is one misunderstanding in the student's mind about the mechanics, is that in the dynamics means these three equations, it's never these three kinematic equations. So definitely force is not present, and if we know this, then such part is a part of the kinematics. But as per these kinematics equations are concerned, later on I'll tell when to use. So like this, in the beginning, just you must have the idea that what is the static portion and what is the dynamic portion, and in the dynamics what is kinematics and what is kinetics. And if we know this clearly, then there will not be any problem for the studying the mechanics. Then generally we study in the beginning that statics portion, and in the statics portion the very first topic is going to be, in general, it is going to be resultant. And in this resultant topic itself, we study the composition of forces, resolution of the forces. So later on in the depth, one by one I'll tell, but in general, I'll tell what is composition and what is resolution. Means if we have to combine the forces, and if we have to convert all the forces into a single force, then that process is called as composition of forces, and that single force is called as a resultant. Means in the mechanics, well in the beginning this topic is going to be there. Then again in case of resultant, so there will be the resultant of concurrent forces and resultant of non-concurrent forces. When resultant of concurrent forces are there, so if only two forces are there, then there is a very simple way by using the parallelogram law. Means R is equal to under root P square plus Q square plus 2PQ cos theta. By using this formula or by using the parallelogram law, easily we can solve the problems of resultant of two forces. And when more number of forces are there, then we have to use the composition by resolution. Then resolution is what? So when any inclined force is there, if we are converting it into a horizontal and vertical component, if it is inclined, its horizontal component is going to be that F cos theta, that theta is going to be its inclination, and vertical component is going to be F sin theta. And if angle is with vertical, then vertical will be cos component, horizontal will be sin component. So this must be also very clear. Otherwise we should not say always horizontal component is cos and vertical is sin. It depends on the angle. If angle is with horizontal, then horizontal is cos and vertical is sin. If angle is of the force is with vertical, then vertical is cos and horizontal is sin. At the same time, it's not necessary that always we should resolve the force in the direction of in the horizontal and vertical direction. Sometimes there may be some inclined planes are there. So we can resolve the force with the same concept along that plane and perpendicular to that plane also. So such type of resolution you must know neatly. It's not difficult, and once we start resolving the force, then that resolution concept we can use for finding the resultant of more forces. Means if more than two forces are there, we cannot use parallelogram law. Then in that case what we'll have to do? So if suppose four concurrent forces are acting, then first all these four forces you resolve horizontally, then vertically, then add all these forces along x direction and y direction. At the same time you have to consider the proper direction also. So generally I'll suggest any force which is acting towards right, consider positive, towards left, negative. A force which is acting vertically upward or in upward direction, consider as positive, in downward direction, consider as negative. So in general, I'll suggest somebody, if they are using some different direction, there is no problem. But my suggestion is that, so you have to choose the directions like this, and by using these directions, you can add all the forces in x direction as summation fx, all the forces in y direction as summation fy. Then number of forces will be converting into two forces, and we can calculate their resultant. Means in short, for concurrent forces, either we can use parallelogram law or we can use composition by resolution, means R is equal to under root summation fx square plus summation fy square. So this is something about the resultant of concurrent forces. And if there is a resultant of non-concurrent forces is there, or whenever the non-concurrent force comes into a picture, there is one more very important term in the mechanics, its entry will be there, and that is what? Moment. So one thing please remember, that if non-concurrent force system is there, then and then only there will be a moment. Then moment is what? It is nothing but it is the turning effect produced by a force. It is the turning effect produced by a force, and its value is F into D. That force is going to be its magnitude, and the point from which we are calculating the moment. The perpendicular distance of that point from the line of action of that force is called as a momentum. And this value F into D, it is the moment, and its unit is what? Newton meter. And again, in the moment, if you understand this concept thoroughly, the moment concept, then you will never find any difficulty in the mechanics. And if that moment is clockwise, because of the application of the force, if something is rotating in clockwise direction, you consider it as positive. In some books, some teachers may be telling anti-clockwise positive. It is not wrong, but I'll suggest that you use clockwise as a positive and its opposite anti-clockwise as a negative moment for the calculation in the mechanics. So your idea about the moment must be clear. At the same time, what is couple, that also you must know. Couple is nothing but it is a special case of the moment, and it comes into picture when two parallel forces are there. If two parallel forces equal in magnitude and opposite in direction, then there will be the formation of a couple, and that couple value is also one of the force into the distance between them, means it's just like the moment. It is a special case of the moment. So later on in depth we'll discuss about couple also. But when non-concurrent force system is there, you must have the awareness about the moment and the couple. Then for the resultant, what it requires? So just like concurrent force system, for non-concurrent force system also, we can use the composition by resolution, means we can use summation fx, summation fy, you can calculate R, and you can calculate its angle also by using alpha is equal to tan inverse of summation fy by summation fx. Means we get the magnitude and direction, that means angle. But in non-concurrent force system, we have to locate that resultant also. And for locating that resultant, we must use the Varignon's theorem. Means in the mechanics, you must know for what purpose, what is there. So in general, I'll tell Varignon's theorem means it is used for locating the resultant, or if the location of the resultant is known, then we can locate its components also. But in short, you have to remember location of resultants, Varignon's theorem. And Varignon's theorem in short, what is it? Varignon's theorem is nothing but it is the moment of resultant about a point is always equal to the summation of the moments of all its components about the same point. That's all. Means it's not difficult, but we must know what it is exactly, how it is used, and what is the purpose. So just by knowing the name Varignon's, and if we assume that it is difficult, then you will never learn the mechanics. So instead of that, go in depth what it is. And once you start utilizing it, then you will enjoy. So resultant is a resultant whether it is of concurrent forces or non-concurrent forces. Finding the resultant, it is not a tough task. It is almost similar, and when non-concurrent force system is going to be there, additionally only you have to use the Varignon's theorem. So these things you have to remember as per the resultant is concerned. And again, my observation work almost 24-25 years is what? Where students get confused. They never understand the difference between resultant and equilibrium. Actually, resultant topic is different, equilibrium topic is different. Then equilibrium is what? When there is no unbalanced force, means if all the forces are being balanced, then that is the portion of equilibrium. Means in case of equilibrium, actually resultant value is 0. Means in equilibrium our purpose is never to calculate the resultant. Actually that value is itself is 0. Means any students, if neatly if they find the difference between equilibrium and resultant, then it's impossible to face the failure in the mechanics. So for the equilibrium, the major topics in the mechanics, they are going to be concerned with the equilibrium itself. Then in the equilibrium also, what is important? So you must know what are the equilibrium condition, what is the basic requirement of solving the equilibrium problems. The most basic requirement of the solving the equilibrium problems is what? The free body diagram. Means if any problem is there, so we should be in a position to draw its free body diagram, and free body diagram is required in equilibrium. It is never required in the resultant. So this difference you have to understand. And the free body diagram, in short, it is what? Any object, first we have to make it free from all the contact surfaces. And once we make it free from all the contact surfaces, wherever it was touching to some surface, from that there will be a reaction. Reactive force will be there. That we have to show. Along with that, we have to show its weight also. And if some externally acting forces are there on that object, then those also we have to show. And such a diagram, when object is made free from all the contact surfaces, and if we are drawing its diagram by showing its self weight, reactions and externally forces, that is called as the free body diagram. And in statics, apart from the resultant topic, whether it is beam is there or cable is there or trusses are there, everywhere what we do, we draw the free body diagram. Means once we start solving the mechanics problem, automatically we'll become the expert in means drawing the free body diagrams. And free body diagram, that is shortly known as FBD. FBD is very famous name in the mechanics, and we must have the expertise over free body diagram. Again, so while telling this, I missed one of the most important thing in the mechanics, that is what? Weight. And it is my observation that if we start finding out the root causes of failure in the mechanics, that weight is one of the term. So where students, they are not having the clear-cut idea, and they make easily the mistake in it. So the beauty of the mechanics is what? This subject gives us tremendous scope for making the mistakes. A very delicate subject, means easily we can make the mistakes. So for example, weight is what? So generally students never, they assume that, just like in general if somebody asks our weight, actually we tell our mass. It is not the weight. But in general, that practice we follow, and we use the we tell the mass only. But in the mechanics, if we are telling something like that, it is absolutely wrong. If it is 0. So while studying the mechanics, you must know what do we mean by weight. So I'll tell weight is what? It is the gravitational force acting on a body. Means in short, weight is what? It is a force. And which force? It is a gravitational force. And the speciality of the weight is what? Its direction is always downward. It is not only downward, it is vertically downward. Means if somebody is saying that downward, it's wrong in my opinion. So it is always vertically downwards. So this thing you have to remember. Means if any block, any object, if it is kept whether on horizontal surface or inclined surface, what will be the direction of its weight? It is going to be vertically downward. And many students, what they do, if some block is kept on the inclined surface, then they show that weight perpendicular to that surface, and there they make the mistake and they lose the problem. The speciality of the mechanics is what? A single mistake while solving the mechanics problem, it will make you 0. So we cannot, there is a very little scope for making the mistake. And while learning this subject, what is the biggest advantage? Our accuracy will increase. Our concentration level will increase. And if we start solving the problems of the mechanics, the most important, our confidence level will be high. And if any student in engineering, if he or she is excellent in mechanics, they will never find any difficulty in any other subject of engineering. That is the biggest advantage of this subject. So such very simple basic things you have to remember. Along with that, I'll again give little bit review of other topics also. So here today we are not here to discuss each and every topic in depth, but what is there and what are the important things. So generally in the mechanics, which topics we are going to study? In the equilibrium, mostly equilibrium of the concurrent forces. Then what is important over there? Drawing the free body diagram. Then if only 3 concurrent forces are acting at a point, then the best way is what? Using the Lami's theorem. You can think of using the Lami's theorem, but the requirement is what? Only 3 concurrent forces. And apart from 3 forces, if 2 forces are there or more forces are there, or even though 3 forces are there, another option is what? You can use the equilibrium conditions. For concurrent forces, which are going to be equilibrium conditions, R is equal to 0. R is equal to 0 means summation Fx is equal to 0, summation Fy is equal to 0. So like that, either by using equilibrium conditions or by using Lami's theorem, you can solve the problems of concurrent forces in equilibrium. So means lot many options are there while solving the mechanics problem. So that is also one more specialty of this subject. And if non-concurrent forces are there, then in case of non-concurrent forces, one of the best example of equilibrium is what? Beams. When beams comes into a picture, then we must know what are the various types of beams, what are the supports, what type of loads are going to be there on the beam. So these things you have to learn. And there also when non-concurrent force system means moment will be added. Then in equilibrium condition, what will be added? Along with summation Fx is equal to 0, summation Fy is equal to 0, there will be the addition of summation M is equal to 0. Means free body diagram. And then using wisely these 3 equations will reach to the answer. And the same thing is repeated in majority of the topics of the equilibrium, whether it is truss, whether it is cables, or whether it is frame. Means drawing the free body diagrams and using the equilibrium conditions. Somewhere we have to use the equilibrium conditions of non-concurrent forces, somewhere we have to use the equilibrium conditions of concurrent forces. Means for example in case of truss, so for getting the support reaction we have to use the conditions of non-equilibrium forces, means summation Fx, summation Fy, summation M. But if we are choosing the joint method, there in case of the joint, those forces at the joint, those are concurrent, means only summation Fx, summation Fy is enough. And if section method of trusses is there, that is one of the best example of non-concurrent forces, means moment will be being used at that place. So such key things you must remember. At the same time, cable. The biggest advantage of solving the problem of cable is what? So well in advance we know the directions. Means cable is always in tension, means always tensile direction is there. So because of that, so if we know the basics of the cable, then there will not be any problem for solving the problem of cable, and there will not be at any cost negative sign. If somewhere negative sign is coming, that means it is the indication that you are making some mistake while solving the problem of cable. So you can correct it. So like that, again frame also a similar topic, free body diagram, wisely using the free body diagrams and using the equilibrium conditions. Means in short, equilibrium of means equilibrium problems in the statics. Means wisely we have to draw neatly the free body diagram clearly and then using the conditions of equilibrium. And in the resultant topic, never use these conditions. So this difference each and every student must understand. Generally in resultant also we make the calculation of summation Fx. In equilibrium also we make the calculation of summation Fx. But the difference is what? In resultant we calculate that value, and in case of equilibrium we equate that value equal to 0. Such minute differences you must know. then any topic in the statics, it is not difficult. Again, especially in some universities, especially in the Pune University, in the statics, space forces topic is also there. So there also, if you find some techniques, if you extend this idea of coplanar forces into it, that is not the difficult topic. And again for this topic also, so whatever the general ways of solving, instead of that, we can go by some different way and we can get the answer. So when I'll be teaching that space forces topic, I'll teach you, or I'll tell you how the same things can be solved by other ways, and how some different techniques we can use while solving the problems of space forces. And once we start solving the problem of space forces, and if we start getting the correct answer, that will lift our confidence, and that is what required in case of mechanics. So in short, in the statics portion of the mechanics, what we are supposed to do, we have to be very calm and quiet, and exactly we must know what we have to do in the resultant and in equilibrium. Means if we are able to differentiate these two things, then static is going to be easiest one. And apart from this, one of the most important thing which I have experienced, which I have observed, which I have suggested to many students in the mechanics is what? Never make the calculation only once. So if you have to clear this subject, if you have to become very confident in the mechanics, then what you do, whatever the calculations you are making, make at least 2 times. Means for example, I am calculating summation Fx, there are 3-4 terms are there, I will get some answer, suppose 150 Newton. So I will write it, but I will not go ahead. If I go ahead without doing the calculation twice, what will happen? While solving some next step, there will be a question whether my summation Fx is right or wrong. So instead of that, simply if you make the calculation twice, we are using the calculator, it will not take more time. And twice also, if I get 150 Newton answer only, I will be very confident to solve that further portion of that problem. So this is my suggestion to all the students. And even if few students who are failed in the mechanics, if they follow the same study, whatever knowledge they are having, with the same knowledge, even if they start making this one change, instead of making calculations once, make twice. In rare case, it will require thrice also. Means first and second answer is not matching, then you have to make third time calculations, and definitely it will match with one of them. And if it doesn't match, means you don't know mechanics. So this thing keep in your mind. So as per the statics is concerned, the problems are big, calculations are more. So anyway, calculator is there. If we are making nice use of the calculator, then static portion easily we can deal. And if we get the confidence, so definitely their statics problems are going to be little bit time consuming, but repeatedly similar problems will be being asked. Easily we can deal with the statics. So this is all about statics portion, or in short, something about the statics. Now I'll discuss about the dynamics. So actually, dynamics is the real threat in the student's teacher's mind. And why this threat is there? So it's my minute observation. So earlier, as I told, that statics, it requires more time, more calculations are there, it's lengthy. In general, statics part will be earlier and later on dynamics part will be there. So majority of the students or majority of the teachers, while studying or teaching, they consume too much time in the statics itself. And at the end, they get very little time for the dynamics. And when very less time is there in the dynamics, they find it very hard. And that is why everybody finds this dynamics difficult. But my observation or my experience, it is totally different. I like dynamics. I teach dynamics in the beginning. If somewhere there are some problem, means requirements of the condition, means requirements of the university, that we cannot teach dynamics earlier, only few topics, then only we'll teach by that way. But in normal way, if whole subject is there, I'll always teach the dynamics in the beginning just by learning few basics of the mechanics. So because of that, what happens? So if we learn this dynamics portion in the beginning, and if we start solving the problems of dynamics, it gives lot of huge confidence to us. And the speciality of the dynamics is what? If we understand the problems, we can solve very fastly. Means if some statics problem takes 15 minutes, the dynamics problems takes hardly 5 minutes. Means in the statics in the exam, if it requires 1.5 hours, mostly 30-40 minutes are enough in case of dynamics. So such big advantage is there. But for dealing with the dynamics, the requirement is what? All your basics must be clear, and you must thoroughly read the question of the dynamics. You must understand that question, and then you must solve. So as in the beginning I told, so basically we must know what are the kinematics problem and what are the kinetics problems. So sometimes the problems may be same, but they can be asked by various ways. So that is why we must understand all these things and we must go ahead. So in the kinematics portion, basically what you should remember. So in kinematics, the major topics are going to be there, linear motion and curvilinear motion. Then in linear motion also, again there are going to be subtopics. For example, uniform acceleration, variable acceleration. So you must know the neat difference between these two. Uniform acceleration means what? Acceleration is constant. And when acceleration is constant, we can use the equations of motion. And it's one of the best specific example is what? Motion under gravity. So those problems also we can solve by using the equations of motion. The reason is what? Their acceleration is g and we treat it as a constant. So this clear-cut idea we must have. Means if some object is dropped or thrown vertically upward, means we must understand this is the problem of linear motion and uniform acceleration. Use the equation of motion. So don't write at any place any equation. At the same time, so when you are going to use these three equations, precisely write the data of the problem and then take the judgment which equation should be used first. So after making the practice, easily you can take the decision. So very fastly we can solve such type of problems. And the variable acceleration part is what? So there you will never find a is equal to 5 meter per second square. Instead of that, what type of problems are going to be there? A is going to be 5t plus 2, or that constant value will not be there. Some variable is going to be there and it will go on changing. Then such problems, how we have to solve? Either by using differentiation or integration. If displacement is given, for example s, differentiate it, ds by dt, it is going to be v. Again differentiate, dv by dt, it is a. Or if a is given, then integrate, you will get v. Again integrate, you will get s. So differentiation and integration, if you are using neatly, then really you will enjoy this linear motion topic. Again in linear motion, by using the same concepts, it may be variable or uniform acceleration, there are going to be various topics. We can study those, for example, dependent motion or relative motion. So all such topics are going to be there in linear motion. Linear motion is one of the big topic and we must understand thoroughly. Then apart from this, one more very important topic in case of kinematics is what? Curvilinear motion. In curvilinear motion, that can be divided into 4 parts. Rectangular components means motion in x direction, y direction, and then getting its resultant. Then projectile portion. Projectile, one more again very important topic and very interesting topic. So for the projectile, we must know it. Always I tell, it is a special case of rectangular components. Means x direction motion and y direction motion. Where x direction motion is constant velocity and y direction motion is constant acceleration. Means in x direction, always velocity remains same. And in y direction, acceleration remains same. Means in y direction, easily you can use the equations of motion. Such basics we must know. And then again in that projectile, horizontal projection, inclined projection on level ground, inclined projection when point of projection and point of strike are at different level, or inclined projection on inclined plane. So while studying this, some of the wrong things you should not project or you should not remember. For example, what I find that students know that maximum range we get when angle is 45, but it's not 100% true. When it is true, when that projection is on level ground, means when point of projection and point of strike they are at same level, then in that case if we throw something with 45-degree angle, it will be having the maximum range. But if suppose that plane is inclined one, then in that case that angle is not 45. Remember it. So in depth I'll tell later on, but don't keep something in your mind that when alpha is 45, maximum range is there. Yes, maximum range is there, but when on level ground. When inclined surface is there, that angle is going to be either more than 45 or sometimes less than 45. So this thing also keep in your mind. Means in general, in kinematics portion, I'll suggest you, so at any place, without understanding, do not write 3 equations of motion. Only you write 3 equations of motion or use 3 equations of motion when acceleration is constant. At the same time, such wrong things, always 45-degree, so we must understand. Along with that, again, normal and tangential components. Normal component of acceleration, tangential component of acceleration, or NT components, or the same thing we say path coordinates. So there also we must know velocity is always tangential, that's why normal component is 0, Vn is 0, Vt is V, At, tangential acceleration is dv by dt, normal acceleration is v square by rho. Such terms we must remember. Then if we are knowing these formulas neatly, if we understand, if we derive, then easily we can solve the problems of such NT components also. And along with that, the one more point is there, polar coordinates, means radial and transverse components of acceleration velocity. Those also, if you prepare the derivation nicely, then you can remember those formulae easily, and if we remember the formulae easily, we can solve the problems. So all such things you must study, and for facing the mechanics in the best way is what? Do not keep anything for the option. If you keep something for the option, so generally what happens, whatever you keep for the option on that part, mostly there will be a simple problems, and the portion which you have prepared, there may be difficult examples in the examination, and in that case you will lose the mechanics subject. Avoid it. Then what is the option for this? So don't study each and everything thoroughly in depth, but touch each and everything, at least simple portion. Means if on some portion simple problem is asked, you must answer it. And this simple thing, if you keep in your mind, you will enjoy this mechanics subject. And the last portion of this mechanics is what? Kinetics. If we are good in statics, if we are good in kinematics, then kinetics portion is very interesting. Again, it is very simple. It's not difficult. But for that, basics of kinematics are required. Then in kinetics, generally what is there? Only I'll tell the names. Newton's second law is there. F is equal to ma, or resultant force is equal to mass into acceleration. Then work energy principle, that work, force into displacement is equal to change in kinetic energy. It is the work energy principle. Then impulse momentum principle, conservation of momentum, impact. So these are going to be the topics in kinetics. And for that the requirement is what? So as Newton was not there in kinematics, no need of free body diagram, but in kinetics portion we have to draw the free body diagram, and we have to make use of these things nicely. Again, some of you can think of D'Alembert's principle. Again, there will be confusion, many problems. We can get the answer by Newton's second law, by D'Alembert's principle, by work energy principle, or even though by impulse momentum principle. Then which should be used? So that is your choice. When you are having a lot of choice and your knowledge is good, the method which you will find simple, that you can use. But in general, my observation, so I'll give the suggestion that if more information concerned with acceleration is there, always you use either Newton's second law or D'Alembert's principle. And the more information regarding the velocity is there, then you use work energy principle. So all such techniques, when we'll adopt, when we'll learn, so if we are making the practice of the problems of the mechanics. So in short, I'll tell, don't take the tension of this mechanics subject. Each and every part of the mechanics, at least very simple, the beginning part, you try to learn, try to solve the problems. In the beginning, you may make the mistake, but once we start getting the answer, that confidence itself will help us. And be confident while dealing with the mechanics. Before taking the subject in the hand, you should not think that this subject is difficult. Definitely, if you do this, that subject will become more difficult. And with confidence, happily, if you face this mechanics subject and if you follow the proper path, then you will enjoy this subject. And that is the only reason that right from the beginning of my engineering career, even though I'm mechanical engineering graduate, mechanical engineer, I'm dealing with this subject. Not only dealing with this subject, I'm enjoying this subject. The only reason is what? This subject is having lot of potential and many engineering applications. Each and everything, everywhere mechanics is involved. How I'm standing, how I'm sitting, how I'm walking. So in all these activities, mechanics is involved. And if you learn this subject and if you implement in your life, that will be the best thing. Means do not learn this mechanics subject only for clearing in the first year. Instead of that, for making your life very interesting, learn this subject. Thank you. Thank you very much.